Data structures. So, what exactly are data structures? Well, a data structure is a storage mechanism used to organize and store data on a computer. It provides a systematic way of arranging data so that it can be easily accessed and updated as needed. But remember, data structures and data types are slightly different. Data structures refers to the collection of data types arranged in a specific order. It's crucial to choose the right data structure for your project based on its requirements and complexity. For example, if you need to store data sequentially in memory, an array data structure would be a suitable choice. Now, let's explore the two main categories of data structures, linear and nonlinear. Linear data structures. In linear data structures, elements are arranged in a sequential order, one after the other. This makes them relatively easy to implement and understand. However, as the complexity of your program grows, linear data structures might not always be the most efficient choice due to the operational complexities. Let's take a closer look at some popular linear data structures. Array data structure. In an array, elements are stored in continuous memory locations. All elements in an array are of same type, and the programming language determines the allowable types. Stack data structure. A stack follows the last in, first out principle. Imagine a pile of plates. The last plate added to the pile will be the first one removed. Queue data structure. In contrast to a stack, a queue operates on a first in, first out principle. Think of a queue of people waiting at a ticket counter. The first person in line will be the first one to receive a ticket. Linked list data structure. In a linked list, data elements are connected through a series of nodes. Each node contains the data item and a reference to the next node. Nonlinear data structures. In nonlinear data structures, elements are not arranged in a sequential order. Instead, they form a hierarchical relationship where one element can be connected to one or more elements. Here are some examples of nonlinear data structures. Graph data structure. In a graph, each node is called a vertex, and these vertices are connected to one another through edges. Some popular graph-based data structures include spanning tree and minimum spanning tree, strongly connected components, adjacency matrix, and adjacency list. Tree data structure. A tree is also a collection of vertices and edges like a graph. However, in a tree data structure, there can only be one edge between two vertices. Familiar tree-based data structures include binary tree, binary search tree, AVL tree, B tree, B plus tree, and finally red-black tree. Linear versus nonlinear data structures. Linear data structures involve arranging data items in a sequential order, one after the other, all present on a single layer. Traversal occurs in a single run, sequentially passing through all elements. However, this may result in less efficient memory utilization and the time complexities increases with data size. On the other hand, nonlinear data structures arrange items in a non-sequential, hierarchical manner across different layers. Traversal requires multiple runs, and memory utilization varies based on the structure's efficiency needs. Notably, the time complexity remains constant regardless of data size for nonlinear structures. Understanding these differences will help you make informed decisions when choosing the right data structure for your projects. So, let's move on to our next lesson and explore each data structure in detail.